So welcome if you're just joining us. I'm sorry I forgot to record from the very beginning, but we just started trapezoids. The definition is a trapezoid is a quadrilateral with exactly one pair of opposite sides parallel. Cool. This makes it different than parallelogram because parallelogram has two sides that are parallel, and it's different than a kite because a kite has 0 sides parallel. Now we're going to get into some other definition-y words. So A, B, and DC are what we call the bases. And the bases are the sides that are parallel. Sides that are parallel. On the contrary, AD and BC are called legs, and those are the sides that are not parallel. Legs, and they're the ones that are not parallel. Cool. Pretty easy so far. That being said, I've got base angles. My base angles are the ones that are on the base together. So D and C are base angles. And also A and B. Another thing to remember is that quadrilaterals add up to 360. So sometimes we forget that we're still in quadrilaterals. We still have that as like a tool in our tool belt. So make sure that you use that when possible. All right, any questions so far? All right, let's keep going. Definition: a trapezoid with congruent legs is called an isosceles trapezoid. It is so quiet today. Who do we think is the culprit for why it's so quiet? Tamara? I think it's Caleb. I hope he watches this video. He got a call out. Yeah, he's not feeling good. Caleb, if you're watching, we miss you. I know you're not watching on Zoom, but if you watch this later. And it's so quiet because you're not here. All right. I hope he appreciates that. Okay, isosceles trapezoid. It's important that we talk about that because the next two theorems are based on isosceles trapezoids. Okay, so the first one says if a trapezoid is isosceles, then each pair of base angles is congruent. Each pair of base angles is congruent. Above there, we just marked the base angles, but they were not necessarily congruent. In an isosceles triangle, they are. So that means that AB, angles A and B are congruent, and it means that C and D are congruent. So I'm going to go mark that. What I also want to point out right now while we're looking at this picture, do you see how I have one pair of sides that's parallel and then one pair of sides that's congruent? Remember when we learned about parallelograms and I told you that in order for it to be a parallelogram, the same side had to be both parallel and congruent in order to be a parallelogram? This is exactly the reason why. This is an example where I could have one side be parallel and one be congruent, and that's a trapezoid, not a parallelogram. So that's kind of tying everything all together if you were still confused on that. This next one says if a trapezoid has a pair of congruent base angles, then it's a isosceles trapezoid. If you look at those last two theorems, if a trapezoid is isosceles, then each pair of base angles is congruent, and then we flip it, we do the converse. The trapezoid has one pair of congruent base angles, then it's isosceles trapezoid. In last period, I really stressed out that it has a pair. It has a single pair. One single pair. I don't need to prove that both pairs work. I need to just show that one. If you have one pair of congruent base angles, then it, by definition, by this theorem, is an isosceles trapezoid. So I'm going to mark on my picture AD is congruent to BC. All right. Any questions? Any thoughts? All right, let's keep going. The next one, a trapezoid is isosceles if and only if its diagonals are congruent. Just like a rectangle and a square, trapezoid, our isosceles trapezoids have congruent diagonals. So ABCD is isosceles if and only if, I'm going to say AC is congruent to BD. AC is congruent to BD. All right. Any questions on those theorems? Those are all isosceles triangle or trapezoid theorems. We've got one more idea to learn, and then we're going to do some practice problems. This is mid-segment is next. Do you guys remember mid-segment when we talked about that in chapter 3? Or did you guys all black it out of your memory? It's there? We remembered it? Awesome. Does anyone remember what it is? What is the mid-segment? Right there. On the chair. No, I'll take this. But you could that's yours. Jared, open it up. Look at the third page or all your formulas. We can rip it up. Oh, not okay. Let me rephrase that. You can tear it apart. You can't rip it up. We can rip it. I just take you go over there. Working over the question. Wait, Jay, did you tell me what a mid segment was? Oh, did I mishear you? Kamar, you know? Okay, good. I love you that you gave me a property. That's awesome. And we're going to use that in a second. What physically is a mid segment? It's a segment, good. It's a line that connects what two things? Two midpoints. It won't matter for you. A mid segment of a trapezoid is a segment that connects the midpoints of the legs. So in this case, it's not just any midpoints, it's the midpoints of the legs. Now, Kamara gave me half the theorem that we remembered. So Kamara said in a triangle, mid-segment is equal to half of the opposite side. Do you remember the other property that we knew about mid-segments back in triangles? It's just a word. We learned two properties of mid-segments back in chapter 5. One was that it's equal to half of the base of the other side. Its length is equal to half the base of the other side. And then the second thing was like how it related to the other side too, and it was just a word. Great job, Cooper. After I wrote Parallel. It's parallel to. I didn't really give you great lead ups to that, but if we remember, Kamara did a great job remembering the formula for the length, but it is parallel. Yeah, Cooper? Of course. It's parallel to each base, and its length is 1/2 of this. In this case, now it's not just of one base; it's the sum of the bases. So if I give you how long BC is and AD, we would add them up together and then divide by 2. So if that's the case, looking at my example, MN is that mid-segment. MN is parallel to what side? What side is MN parallel to? I think I heard it. AD. Drew, do you know what else it's parallel to? BC. Very good. And then to show its length, I would say MN is equal to 1/2 of AD plus BC. All right. Any questions so far? All right, flip it over. We're going to do these problems in a second, but I want to skip and go down to the sometimes, always, never. We will not do this proof today. We didn't do it last year on the notes that I have, so we're not going to do it this year. If I change my mind, I'll teach it to you on Tuesday or Wednesday or Thursday, whatever day I see you. We're going to do sometimes, always, never, and I want you to stop and think or do it by yourself or with a neighbor, and I want you to decide if it's sometimes, always, never, okay? We'll go over it together in a minute. Think by yourself or do it with a neighbor. Sometimes, always, never for these problems. Try it yourself. You're trying to sometimes, always, never on your own. Yep. All right. Even if you're not done, take a second, finish the one you're on. Let's talk about them together. Cooper, you got number one? Awesome. What do you think? A trapezoid is always a parallelogram. Why is the trapezoid never a parallelogram? Kate. How many parallel sides does a trapezoid have? How many parallel sides does a trapezoid have, Kate? One. And then how many pairs of parallel sides does a parallelogram have? Two. So that's why. Very good. Exactly what you're saying. Is that what you're going to say, Cooper? Awesome. All right. Somebody else. Number two, the base of trapezoids. Ooh. The bases of a trapezoid are a blank parallel. Always. I literally told you that when I told you what a base was, right? I said they're the sides that are parallel, so that means that they're always that. What about the base angles of an isosceles trapezoid are blank congruent? Cooper? Not sometimes, always. What's the key word here that makes this always and not sometimes? Isosceles. If I had just said the base angles of a trapezoid, then you're right to say sometimes, but because I told you it's an isosceles trapezoid, that is definition always, 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 always. What about the next one? The legs of a trapezoid are blank congruent. The legs of a trapezoid are blank congruent. I gotta call on somebody else, Cooper. I don't care. Lydia? I would not say always. Sometimes. Why is this one different? Why is this one only sometimes? Do you know what word it's missing? Good. So if it said isosceles, then we would say always, but since it doesn't, it just says a trapezoid, we're going to say sometimes. And that's the same as the last one, so I'm crossing out that last one. So sometimes I throw in that word isosceles to make it always, and sometimes I don't. So you got to be careful. All right. Consecutive angles of a trapezoid are blank supplementary. Thanks, Brooke. Right there. Consecutive angles of a trapezoid are blank supplementary. Drew? Always. Ooh, this one's tough. I'm going to say sometimes on this one. Let me show you why. If I look here, I would argue these are supplementary, yes, but I would not say that these are supplementary. Because those are still consecutive. They're still next to each other. That's a tough one. That's one that I did to trip us up. Does that make sense? Yeah. So I would say sometimes on that one because it could be, these are still consecutive because they're next to each other, but they're not necessarily not congruent or supplementary. The diagonals of a trapezoid are blank congruent. Diagonals of a trapezoid are blank congruent. Mar? That one is sometimes. What if I had said the diagonals of an isosceles trapezoid are congruent? What would you say? Always. Do you see how that isosceles throws a lot of always in there? And if I don't say isosceles, we got to do sometimes. Good, good, good. All right. Again, we're going to step number 4. So we're going to go back up to the top. We're going to do 1, and then we're going to do 2. And then we're going to be done for today. So number 1, I've got find the missing angle measures. Cooper, you know one of them? Which one you know? D, awesome. How do you know D? Good. So Cooper did 180 minus 53, and what'd you get? Awesome. Okay, who knows another angle? Tamara? Is that a hand? Okay, nope. Oh, you want to go for it? I don't know. Is it? Why not? Kate, you had your hand up. Do you think it's isosceles? Yeah. I think so. Why? Trust it. It tells you it's congruent. That means it's isosceles. So, Kate, do you know one of the angles? Good, you know both of them. Because it's isosceles, I know that these two are congruent. And then Cooper did all the hard work for us. These two are congruent. All right. Questions, thoughts, comments, concerns? Yes, Lydia. That means it's an isosceles trapezoid. So one pair of parallel sides and then the other sides are congruent. That's an isosceles trapezoid. Good question. All right. Any other questions, thoughts? All right, move to the next one. Now, is this an isosceles trapezoid? Why not? Because what? There's no congruent marks. Good. I just couldn't hear you. There's no congruent marks. It's not isosceles. So now we got to do a little bit of work to find it. Who wants to help me find one of the angles? You what? What's your theory? Ooh, is that good enough excuse in geometry? Cooper, you're right that it's almost 90. Donna, what did you just tell me? A and D are supplementary, so how would I find D? 180 minus 91. So it's going to be 89, which is almost 90. But just because something looks like 90 is not a good enough excuse. That's not like a reason I can write. It looks like it's 90. Pull it together. Pull it together. What's angle C? What's angle C? How do I find angle C? I can think of two different ways to find it. Who wants to give me one way? Cooper, what's the way you're thinking? Good. Why? They're supplementary. If you guys remember all the way back in chapter 3, if I've got parallel lines and transversal, we've got congruent and supplementary angles. So that's literally, we've been using angle or unit 3 for weeks and weeks and weeks and weeks. So that's why Cooper knew that we were able to minus from 180, and that's going to be, what is it, 48? What's another way? Did anyone think of it differently? Kate? Perfect. Plus, 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 and if we had made this x, set m equal to 360, that would have worked too. Good job, Kate. Either way is correct. No way is more correct than the other way. Cool. Jackson, you done? Oh no, I just was wondering. You just didn't have your pencil in your hand, so I just was wondering. Next one. Find the missing angle measure. So I have W and I have T, and we got to find all the missing ones. Who wants to find one missing one? Cooper, give me one. W is, no, I already knew that. Something else is 90 though. What, Cooper? Z. JJ, what do you know? Okay. Why do we know that? They're supplementary. We've got these parallel lines. We know that transversal means that they're supplementary. Good. JJ, what else do you know? Oh, nothing? Is that you, Cooper? Cooper, you gotta stop talking with your mask on. I can't tell who's talking. I thought you still had your hand up, though. With the bottom right one, yeah, why? Supplementary again. Very good. What else do I know? I watched you just hit yourself in the face. I totally watched you do that. Kamara. R equals 90. Which one? Oh, the top. Both of them. Both of the angles at R are 90. So WRT, that angle is 90, and then TRZ is also 90. What do we call RT? What is that? It's a mid-segment. So RT is a mid-segment. And what do I know about how the mid-segment relates to the opposite, the bases, the opposite sides? Parallel. Very good, Donna. And then what else do I know about it? Well, I guess never mind. Hold that thought. If you know what else I know about it, hold that. I'm going to ask you about that in a minute. Let's find the other two missing angles. Cooper, give me one. Okay, let's call it RTX. Let's not call it top T. Why is that 50? Ooh, that's what I want to talk about. What are these angles? Corresponding. That's it. Again, everything goes back to chapter 3. We're all just building, building, building. So if our foundation is weak, then our building is going to crumble down. But if it's strong and we remember parallel lines make these congruent angles or corresponding or consecutive or whatever, then we're going to keep building on up. I have one more angle I need. What is angle X? True? Yes. Why do you know that? Good. Same reason for everything, right? They're either supplementary or the corresponding angles. There's a lot of reasons we can use. Very, very good. All right. The last thing we need to do is this letter B. Suppose WX is 4A minus 9. We're going to stop everything and label our picture as we go. 4A minus 9. ZY is 2A plus 5. And then RT is 16. Now, I asked a minute ago, what else do we know about mid-segments? And I said, no, I'm going to ask you about that in a second. Now, what's the second thing we know about mid-segments? How am I going to solve this, JJ? I would not times the top one by 2. I'm going to multiply by 2, but not just the top one. Kate, what are you thinking? Find like y is 2a plus 5 equals 2 times 16. Almost. I need more than just that, Melissa. Good. So this is either equal. I'm going to write this 2 ways. So I have to do the sum of the bases, not just the top, not just the bottom. I have to do the sum of the bases. And we can either do 1/2 of the sum of the bases equals the mid-segment, or we can write 2 times the mid-segment equals the sum of the bases. Good. A lot of us knew to go and do 2 times 16, but I want to remember it's the sum of the bases. Good job, Melissa. Are we okay if I write it like this, or do you want me to put the 1/2 back out front? 2 times? Okay, we'll do this. Now we're just solving an algebra 1 equation. Combine like terms, multiply, blah, blah, blah. All that fun stuff. That's 6a minus 4 equals 32. 6a equals 36. A equals 6. Cooper, question. The 5 got combined with the 9.
Massive L.
Okay. Oh, Jared.
Okay.
Oh, we'll talk next week. Have a great weekend, Jared. Huh?
I just have no idea.
Are we gonna talk next week?
Yeah.
Do you know, Brooke?
Sorry.
Well, we will talk next week. Cooper, can you not? Okay, I was distracted, but we got A. Any questions on how we got A? Let's find WX and ZY. Okay. How do we find WX and ZY? What do I do? Plug them in, right? 4 times 6 is 24 minus 9. 24 minus 9 is 15.
Thanks.
Bye. Thank you, Brooke.
Sorry.
It's okay. We'll talk next week. It's just hard to grade tests that are so bad. Because I want to find as many points for you, but sometimes I'm just like, there's no points to find. If I'm feeling generous, we'll do some, I'll give them a second chance, but we'll see. This was a test they took like a long time ago, so we haven't talked about this stuff in weeks, so they just didn't remember anything. That's why I told you guys you have to take your test on Tuesday, because then you're going to get to this point and be like, I don't even know and I don't even care. And so we just got to get it done. So that's a mess I'll clean up later. That's okay. I appreciate that they came in. At the end of the day, we just got to take ownership for our grades and do what we got to do. So it won't be that bad. They'll be okay in the end. It is just frustrating to have a bunch of blanks on a test. Okay, let's keep going. And then what's the last one? 2 times 6 plus 5 is 12 plus 5 is 17. All right, I think that's it. Sorry, I was all over the place during this lesson today, guys. I did record this so you guys can watch it back later. Hopefully seeing it or rewinding it, etc. will help you find any missing errors. But we do have a test next week. So next time I see you, we will review and then we will test. So if I can do my best, I'll try and put the review online this weekend if anyone wants to get a head start reviewing. And then we will, I don't know what next week looks like. It's a mess with the days. I think it goes day 5, then day 3, then day 2, then day 1. I don't know. I barely know what's going on day by day. So I'm trying my best and I'll just tell you guys as much as I know when it happens. But I will stop my recording so everyone can stop listening to talk.